So, hello, I'm Sujit,
And I'm Bohan.
and so our project is Smart Lecture. So, what Smart Lecture does is that you take in a CS related YouTube video lecture. Yeah, demo it here.
Dividing it in half, and in general, as we'll see, when I know what
And
my space
you
of
input it into the
answers is,
website,
I
hit
always,
generate,
as my
and
next guess,
it
choose
creates
something halfway
a
along that
text
line.
summarization of the
I
most
made a guess
important
and
parts of
say
the
it was too
lecture.
small, and I know the answer is between here and here.
There we go.
This was too small. I now know that the
So first what we did to train Word2Vec, we had to gather a large database of CS-related lectures. So first I scraped the Wikipedia page for the glossary of computer science, which scraped the website and returns a list of all of the terms on that page. Then next, scraped YouTube, searching YouTube for all of those glossary terms that I found previously on Wikipedia. And basically, this function will take in a search query and output a list of videos from YouTube relating to that topic. And basically, those two functions are used in tandem here to generate a large CSV file of YouTube links relating to computer science.
After getting those URLs of CS-related videos, I used an web API that could download the subtitles of those videos, and we download those subtitles and build them up into a dataset, which is later used to train our Word2Vec neural network. So for the data processing part, we use Word2Vec, the Python library, to convert words into vectors. Word2Vec is based on a neural network that learns from the context of each word and yields a really high dimension vector that represents some subtle features of each word. So this is a small demo of the Word2Vector to show that it actually learns those words and knows the meanings of those words.
At a part of the summarization, what I did here is that basically we first used Word2Vec to compare the entire data set of words to the word computer in particular. So basically what Word2Vec did is that it assigned a similarity value to all the words, comparing them to computer. So basically what we do here is that we compare all those similarity values and use a threshold of 0.5 similarity to filter out words from a sentence.
For the AI part, what I did is downloaded lectures from CS195 and mapped those words to 1, and downloaded some random speeches from YouTube and mapped those words to 0. And I mixed them and shuffled the array, then fed them to a 100 by 100 neural network. The classifier basically classifies a word to a value between 1 and 0. The number closer to 1 means the word is closely related to kind of computer science lectures, and they are apparently more important in CS lectures. To make all those scripts we wrote usable for a human user, I wrote a website with Flask, which basically, for the index page, you got a text view and a button. By hitting the button, a JavaScript will read your input in the text view and redirect you to an endpoint that corresponds with your input. at that endpoint, your video ID will be read and passed to subdownload, which will download the subtitle of the video that corresponds with your video ID. Then the subtitle will be cut into sentences, and each word in that sentences will be fed into word-to-vec neural network to yield a vector. And that vector will be passed to the TensorFlow neural network, which will calculate the importance of that word. And the script will basically add up all those importance of those words in a sentence and divide it by the number of those words. If the importance of the sentence is greater than the threshold, we basically chose 0.5. The sentence will be shown in the result.